Follow-up question to this is, how do you know if you're actually right? So once you get an answer, maybe check with your group. Does your answer actually work? Okay, so what would you do to solve that inequality?
Well, I remember learning about inequalities.
And then divide by 3. And then square each one. Then you get the answer. Oh.
So if you like solving it, you don't hear it. Like, will you have to use solving it? You just feel like right. Yeah. Try to solve it. Add 4. So if you're working, you don't know how to use that. Tell me why on this side there's
Here, try this.
Oh, I have the 3 points. I know, right? My bad. I said when I said
Oh my God. No, I don't know how to got there. I promise. I swear.
We look on the period.
broke it too. I didn't break it.
I find that I still
No. You add the plus or minus when you're doing what to solve. When you're solving for x and you're doing what thing for both sides.
Even if it is.
Yeah. Just like when you're taking an even root.
16 is true.
So you're square rooting both sides. If you're fourth rooting, because by taking those roots, you're trying to say like what number multiplies by itself 2 or 4 or 6 times to give me this value. In those cases, you don't know if it's positive times positive or negative times negative. Either of them would work if you're multiplying it enough times. However, if it's the square root of x and it's equal to 4, square it. 4 squared is just 16. 4 squared is never negative 16. You should have that some way. Did you test the numbers?
I use
¿Dónde está la? Caracas, Bogotá, Colombia. La Paz, Bolivia.
What's up? Okay, I'm going to interrupt. Here's what I'm seeing from most people as I walk around the room. Listen up. Okay, most people added 4 to both sides, so we got 3 square root x is less than or equal to 12. And then we're going to divide both sides by 3. And at the very beginning, I heard some really good conversations about what students remembered from Algebra 1. You know, like if I multiply or divide by a negative number, the sign will switch. But in this case, I'm dividing by a positive 3, so do I have to flip my inequality sign? No. Okay, so if you need to jot that down in the margins of your paper, or in the margins of your notes, go ahead and add that to your notes. If you multiply or divide by a negative number, you must change your inequality sign. So like less than becomes greater than and vice versa. In this case, we didn't have that. So if you have something like the square root of x is less than or equal to 4, the next step, thinking about our equations from yesterday, would be square both sides. Okay, if you want to get rid of an nth root, use the nth power. So we're going to square both sides. That leaves us with x is less than or equal to 16. Now, most groups went through that second step of checking to see if they were right. And we check things like nice numbers that we could do square roots of. So we maybe put in 9 or 4 or 1 or 0. For those groups who did that check and thought everything was just dandy, I said to them, well, does negative 9 work? No, why not? It's imaginary. It's a square root graph. So if it's an even root, and you're doing an inequality, you also have to consider what's underneath the radicand, because that needs to be greater than or equal to 0. So what's the lowest value of x that works? 0. So all you have to do to your final answer is add a lower bound. 0 must be less than or equal to x, must be less than or equal to 16. Any of the numbers between 0 and 16 work. Anything beyond 16 is going to be no good. If we put 25 in there, 3 times 5 is 15, minus 4 is 11, that's too big. If we put anything less than 0, we're going to get negatives, so we've protected it on both sides. Okay. So if you wish to jot any notes, directions, hints, troubleshooters, those types of things into your notes, these would be the things very similar to yesterday. How do you solve a radical inequality? Okay, basically the same rules. Isolate the radical. So please don't think that we're reinventing the wheel here. We're still using basically Algebra 1 skills to get x all by itself. Okay, peeling away the layers. Okay, so isolate the nth root. Then you're going to raise both sides to the nth exponent. Consider your radicand, if necessary, and write your solution as an inequality. Now, can anybody tell me, could you think of a time when I don't really care about the radicand?
Never.
I mean, it's not a bad idea to always check. Are there some roots where I won't have to worry? Luke? You raising your hand?
I was thinking this one is just x, so you don't really.
Okay, so you didn't have to do too much, but we did have to consider it, right? Because we couldn't use anything less than 0. Aiden? Okay, even roots are the ones where we have to do this work, right? Okay. Consider the radicand for even roots. Because what's the problem with even roots? Can't do even roots of negative numbers. Do you really have to worry about it if it's an odd root? No. If it's a cube root, I mean, who cares? All the numbers are going to work, right? So then it's just a matter of solving correctly and making sure to switch your inequality if you need to. But you don't really have to consider that other low bound. And I'll also say this for some people who catch on to patterns quite easily. You may also notice you don't really have to worry about it if it's an even root and it's greater than, because it just keeps going. Greater than, that's fine. It's really when it's less than and an even root that you have to worry about the radicand. So I'm going to put up a couple problems I want you and your group members to solve. Talk to your group members. Tell them what you're doing. See if you can agree on an answer. Here are 2 problems for you. I'm going to be walking around. I'm going to be real nosy and peer over your shoulder and look at what you're doing like you love how I do. My niece told me she hates it when her math teacher looks over her shoulder.
There you go.
I did that too. I said it was 210.
What's up? Gucci. Okay, so let's come together and check the board. These are the things I'm seeing and hearing as I move around the room. The first one, of course, you're going to divide by 4. You're going to cube both sides. You get x plus 1 is less than 8. And then you subtract 1, so you get x is less than 7. Notice, why don't I say 0 is less than x is less than 7? It's a cube root. So could I put negative 1 in here? Oh, could I put, let's say, negative 9 in here? Sure. Negative 9 plus 1 is negative 8. Cube root negative 8 is negative 2. 4 times negative 2 is negative 8, and that's less than 8. So I can take odd roots of negative numbers. There's no low bound for me. Think about your graph of the cube root function. It continues forever left and right. So you don't have to restrict it on that side. On the second one, you're going to add 3. You're going to divide by 2. You're left with square root x is greater than or equal to 3. You're going to square root both sides, and you've got x greater than or equal to 9. Why didn't I put in these zeros in that inequality? It's greater than 9. I don't have to worry about that whole going less than 0 and under the radical. So that's not going to be an issue for me. Of course, I'm only going to put things greater than or equal to 9 in here, and they're all going to work because they're all going to be positive because they're greater than 9. Okay. Excuse me. Okay, one more. Let's see. Where's my little cursor?
Yes.
Very good. Very good. Very good. Okay. See, today you're paying attention. This is negative 2 square root x greater than or equal to negative 8. What are we going to do first? Divide by negative 2.
Flip the sign.
Which means we have to flip the sign. So we have square root x is less than or equal to positive 4. Okay. What are you going to do next?
Square both sides.
Square both sides. So we get x is less than or equal to
16.
16. 0 is less than or equal to x is less than or equal to 16, right? So this is one where we have to now reconsider the radicand because it's a square root less than a number. And doesn't that make sense? Like you can't put negative 1 in here because then you would get an I, and that wouldn't, we don't compare 2i or negative 2i to negative 8. Okay, any questions, concerns from me? Okay, I got one more. What would you do? Rihanna.
So, can any of these
I mean, yes, I suppose there could be an extraneous, or not, there could be no solution to an inequality. However, you aren't going to have to deal with extraneous solutions when solving the inequality. No, you won't have to worry about that. And like on this one, like you should really have like this is an even root, but it's compared to a positive, not a negative, so I don't have to worry about it. No, I won't add that in. Check for extraneous only really with solving. Okay, okay, one more. You try something. What would you do to solve this system? And I'm just going to let you kind of chat out ideas with your group members. So y squared equals 4x plus 17 is one equation that we know. Y equals x plus 5 is a second equation that we know. And I'm asking you to solve a system. What is the x and y that works for both?
Hey, Doy.
May I interrupt and ask, does the A group have like a tip of where to start when solving a system? What's something we might do? Getting down to one variable in an equation, how are you planning to do that?
Sub it in.
You could use substitution. Sure. I mean, someone I heard say elimination. You could try to eliminate a variable. What a variable would we be able to eliminate if we chose an elimination method?
X.
It would have to be x, okay, because that's the only variable that appears in both. But as I move around the room, I think most people are doing substitution. So if y is x plus 5, then that's x plus 5 squared equals 4x plus 17. Oh, and what is x plus 5 squared?
It's x squared plus 10x plus 25.
Thank you, beautiful. X squared plus 10x plus 25. No need to mention September 17th today. Very good. And then what would you do from here? Says equal to 0. It's quadratic now, right? So we're getting x squared plus 6x plus 8 equals 0. Factor x plus 4 and x plus 2. And so my solutions are x equals negative 4 and x equals negative 2. Is that my answer? Anna says no.
Oh, you have to plug it back in.
Oh, we gotta find y. We only have x.
No way.
Okay, so probably the easiest way is to say y is equal to x plus 5, right? So if x is negative 4, then y is 1. If x is negative 2, then y is 3. So my two solutions are negative 4, 1 and negative 2, 3. Ooh. How would you know if those answers are right? How would you check them? Yeah, put the x and y into both equations, right? I mean, they should both be true. I'll just choose like -4, 1. -4 is x. So 4 times -4 is -16 plus 17 is 1. Does that equal 1 squared? Yeah. If I plug them in, well, I kind of know it already works here, but y is 1. Is that equal to -4 plus 5? Yeah, so it worked in that equation. And then if I plug -2, 3 in, that will work for both of them as well. Yeah, you gotta find y. That's in a system. Remember, we did systems back in chapter 1. If it's 2 variables, you gotta find both variables. If it's 3 variables, you gotta find order triple, x, y, z. Can someone explain to us what we're finding? What are those points? What's that? Points on a graph? Luke?
Well, it's a system, which means it's two equations, so it's where they intersect.
It's the points of intersection for the 2 equations. Okay, so these here are the points of intersection for the 2 equations. Usually, like back with linear systems, there were just 2 lines. So lines could cross 1 time if they were making an x. They could cross 0 times if they were parallel. They could cross infinitely many if they were the same line. But now we're having 2 lines or 2 functions that are, or 2 graphs, I suppose, that are intersecting 2 times. What shape is this graph going to be? That's a parabola that opens right or left, right? This is a line. Could you imagine a parabola that opens right or left and a line intersecting at 2 points? Sure, visually it would just look something like this, right? Okay. So what we're finding are where those 2 points are on the coordinate plane. Yeah, you guys are really smart. You did really well.
Are we doing that tomorrow?
That was today. You did it. Give yourself a hand. Nice job. Okay, we got 12 minutes. I'll pull the problems back up on the board. Everybody should be working. If you need to check your answer key from last night, let me know.